Let's take a look at Sequences 3.1, this first homework. Okay, so this first one we're just solving some equations. We start out with simple and get a little more complex. But we are just taking a look at these. Now remember, a few things about equations. Okay, they have that equal sign. So essentially what we're doing is we're trying to change the sides so that they're always equal. We call those equivalent equations. And we're trying to get it down to just the variable equals, or something equals a variable. So to do that, we have to kind of undo what's been done to our equation. Okay? We have to think about what's happening to the variable and then undo it. So if we look at number 1, 3x equals 27. So if I put a number in for x, we would take that number and we'd times it by 3, and that would get our answer, right? So if we had that x, we'd times it by 3, and that would get our answer. So to solve it, we've got to do the opposite in reverse order. So instead of timesing by 3, we need to do the opposite, which is divide by 3. So I divide that left side by 3. But in order to keep this equal sign, I have to do it to the other side. 3 divided by 3 gives us 1. X equals 27 divided by 3 is 9. 1x is basically just x, because 1 times anything is just itself. So we get x equals 9. And so if you struggle with solving equations, think about doing something like this and make kind of a chart and say, okay, I've got x. What did I do to x? Well, if I have x as a number, I would add 56 to it. That would give me my answer. So I need to do the opposite. The opposite of adding 56 is subtracting 56. So I'd subtract 56 from both sides. We'd end up with x equals, let's see, borrow from the 1, get 13. Borrow from the 13 to get 12. Okay. Actually, probably did that backwards. It's been a while since I've been borrowing. 13 minus 6 is 7. 12 minus 5 is 7. So we get 77 for our answer. Alright, let's take a look at number 3. So same idea, 7 equals x over 5. Okay, so now we've got to get that x. What's happening to our x? Well, a fraction bar also means divide. So we're dividing by 5. So what do we have to do? The opposite, which is timesing by 5. So I times both sides by 5. Dividing by 5 and timesing by 5 eliminates it, so we get x equals 5 times 7, which is 35. So 35 equals x. And if you want to, check it. Is 35 divided by 5 7? Yeah, it is. You can always put your answer back into the original equation and see if it works out. Okay, number 4. So we've got x minus 44 equals negative 32. So what's happening to our x? Well, we're subtracting 44, so we need to do the opposite. We need to add 44. So we add 44 to both sides. Those give us 0. X plus 0 is just x. And negative 32 plus 44, that's like 44 minus 32, right? So we get 12 in the positive. So x equals 12. Okay. Now let's take a look at number 5. Now we're getting a little more complex. Okay. So there's a few different routes we can take on this one. I'll do them both and explain both of them away. Okay. You could start out the way I have been and say, okay, what am I doing to x? If x were a number, thinking about the order of operations, we deal with parentheses first, right? So we would add 6 to x, Then once we had that number, we would times it by 3. So if I want to go and solve for this, we do the opposite in opposite order. So instead of timesing by 3, I start out by dividing by 3. So I divide everything by 3. Those 3 become 1, which is multiplying by 1 doesn't do anything. 54 divided by 3 is what? It goes into a 1, 18. Then the opposite of adding 6 would be subtracting 6. So I'd subtract 6. We'd get x equals 12. There's my answer. Okay, that's one way we could do it. The other way would be to go like this. Would be to say, okay, I know that I can distribute that 3 in the parentheses, so I'm going to do that. Because I can simplify. Okay, so 3 times x is 3x, plus 3 times 6 is 18, equals 54. Then we can think about, okay, what happened to x? Well, first we times it by 3. In this situation now, then we would add 18 to it. So we go backwards in opposite order. So first I subtract 18, then I divide by 3. Because we got rid of our parentheses, we do multiply first, whereas this one we did it second. So subtract 18 first. That's our first step. We get 3x plus 0. That doesn't do anything, so we just get rid of the 0. 54 minus 18 would be 36. Divide by 3, because that's our second step. We get x equals 12, our answer. So we get to the same answer, but there's often multiple ways to do that. Alright. So x equals 12. Alright, let's take a look at number 6. Now 6 gets a little tricky. We've got 4x plus 64 equals negative 7x minus 35. Now this one, because it has variables on both sides, we need to get the variables on the same side. Okay? Because that way of making that little chart and deciding what's happening to x, we got multiple things going on here. So it's not as simple. Okay, that really only works when you have one variable. But we can combine variables. Okay? Because remember, this 4x is really like x plus x plus x plus x, right? Plus 64. And this negative 7x is 7x is just negative versions of them. Negative x plus 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 negative x minus 35. Okay? And so what you can kind of think about is that we want to combine those. Okay? But that's all the 7 times x means, is we've got a ton of those variables. So we can put them all together and see how many we're left with. So there's two ways you could do it. You could subtract a 4x, because that's a positive 4, which you'd subtract a 4x from that side, or you could add the 7x. I'll subtract 4x this time. So that becomes 0, so we're left with 64 on the left side. Negative 7x minus 4x gives us negative 11x minus 35. See, now we can look at this and go, okay, so if I knew what x was, first we'd times by negative 11, and then we'd subtract 35. So we need to go backwards and do the opposite. So I need to add 35 first. So we add 35 to both sides, giving us 99 equals, that cancels out, negative 11x. Then divide by a negative 11. And that'll get us our answer. So 99 divided by negative 11 would give us negative 9 equals x. There's our answer. X equals negative 9. equals x. Same thing as x equals negative 9. Okay, now this last one, we're going to have to simplify it. There's a lot going on here, a lot of x's. So let's get the x's together first. So first thing I want to do is distribute. So I'd go 7 times 2, which would be 14x. 7 times negative 7, negative 49, minus 5x equals x plus 13. So I've got this positive 14, this negative 5x. So I'm just going to combine them. They're on the same side, so I don't have to do the opposite. You only do the opposite when they're on opposite sides. Okay, so 14 minus 5 would give us 9x minus 49 equals x plus 13. Then I want to get this 1x, because it's like a 1x. So I subtract it because it's positive. And we get subtract 1x, so we get 13 on the right side. 9 minus 1 would give us 8x minus 49. Okay, now that we're down to 1x, I can go, okay, first I'd times it by 8, then subtract by 49. I want to do the opposite in opposite order. So we're going to have to add 49 and then divide by 8 to get our answer. So we add 49 to both sides. That would be what? 2, oops, hit the next button. Okay, I'm going to have to do that over here. So we get 2, because that's 12, carry the 1, 1, 2, 62, equals 8x. I just flipped it around, but you can do that on equals. You know, this is the same thing, so it really doesn't matter which way we write it. Okay, so we added 49. Now we have to divide by 8. So we divide everything by 8, and we get x equals 62 over 8. So 62 over 8 would give us, well, let's reduce that. Sometimes our answers don't come out so nicely, don't they? So you could use a calculator and get a decimal, that's fine. Or we could just simplify it. Let's see. 4 would go into 62, right? Goes once, 4, 2, oh, no, 4 doesn't go into 42. Scratch that one. So divided by 2, we'd have 31 over 4, which is 7 3/4, or 7.35, or 75. Yeah, that looks about right. So x equals any one of those. Don't care which one you put in there. Alright. Now, if we look at 8 and 9, okay, now we're solving for the y variable. Now we have two variables, so we're going to try to get the y by itself. So we can think about it the same way. You can say, okay, I want to get y by itself. Well, first, I would add 3x to it if I knew what y was. So I'm going to do the opposite. I'm going to subtract 3x. So I subtract 3x from both sides. Those cancel. I'm left with y equals, which is what I want. Now, here's the tricky part. A lot of you are going to want to turn that into 16x. Okay, that is incorrect. This 19 and this 3x are not the same. Right? Because 19 is a number. 3x is really x plus x plus x. I can't combine those ones. So we just leave it. 19 minus 3x. Some of you may want to rearrange it to look like this. That's the same thing. That's slope-intercept form, by the way, too. Okay? So either one of those versions I accept. Alright, let's take a look at number 9. So, what do we got going on here? We want to get y by itself. So, if I knew what y was, first thing I would do is times it by 4. That would give me a number, right? Then we'd subtract by 7x, and then we'd add that 23, wouldn't we? So we're going to go backwards and do the opposite. So we're going to start out by subtracting 23, adding 7x, and then dividing by 4. Doing the opposite in opposite order. So subtract 23 from both sides. That cancels. We're left with 4y minus 7x on the left side equals 0 minus 23. So negative 23. Okay, so remember that equal sign. Okay, by subtracting this 23, we created another version of this equation. Okay, just things shifted over slightly. Now we can add 7x, those cancel, we're left with 4y equals, now, negative 23 and 7x can't be combined because 23 doesn't have an x. So write 7x minus 23. So we did that step, now we need to divide by 4. So we divide everything by 4. And it's not going to come out to be very nice and neat, that's alright. That cancels, leaving us with y. Actually, it turns into 1, which we can eliminate. 7 over 4x minus 23 over 4. You can turn those into decimals if you want, but that works. So, those ones can get a little uglier, but still the same idea. Okay, now we're going to complete each table. So, all we have to do is figure out what the pattern is. Okay, so from 2 to 4, from 4 to 8, 8 to 16, 16 to 32. Well, we could think we're adding 2. But if I add 2 to 4, does that give me 8? No. So we're probably not adding 2. How else can 2 get to 4? Well, we can multiply by 2, right? 4 times 2, does that give us 8? Times 2, 16. Times 2, 32. Yep. So, times 2, 64. Times 2, 128. Times 2, 256. So you just find the pattern, continue it. Number 11. 66 to 50 to 34 to 18. Well, 66 to 50, we're what? Subtracting 16. Does subtracting 16 give us 34? Yes, it does. Subtracting 16, 18. Yep. So subtract 16 would give us 2. Subtract 16, negative 14. Subtract 16, negative 30. Subtract 16 last time, negative 46. And last one, negative 9 to negative 2 to 5. Well, negative 9 to negative 2, we'd be adding 7. Does adding 7 give us to 5? Yep. Adding 7 to 12. So adding 7 to 19 to 28. Right? No. That one was totally off. Adding 7 to 19 would be 26. There we go. 7 would be 33 and 40. Okay, so just completing each table, which is actually what goes on in the next problems, right? They're just giving you a story problem to do it from. So fill in the table, explain how you'd figure out what would be in cell number 8. Okay, that's the explanation down here. How you'd find that next number. What could you do? So I'm not going to give you guys the explanations. I want you to tell me that part yourself. So first one, remember when we're looking at story problems, we need to figure out where we start. We need to figure out where we're going, what's the growth. So you run a business making birdhouses. You spend $600 to start your business, and it costs you $5 to make each birdhouse. So they've already given us the two groups, remember, which is the first part. The number of birdhouses, total cost to build. Okay, so we're looking at total cost to build. Okay, so we were told we spent $600 to begin with. Okay, so before we built any birdhouses, we had spent $600. Now they started with 1. So if we wanted to, we could write a 0 here and say, well, if I don't build any birdhouses, I still already spent $600. Okay, so now it costs $5 to make each birdhouse. So to that $600 I've already spent, what's the pattern? Well, for each birdhouse, we have to spend $5 more. So 605, 610, 615. Now, you've got a few options here. Once you've started, you could try to make an equation. We're making a table. You could make a graph. You could use any sort of model to help you figure out number 8. Okay? So the explanation would kind of be which tool, which model are you using, and how do you get there. Okay? For this one, it'd probably be very easy to just continue my table. to figure out the 8th term and tell me how I used my table to do that. Okay, so number 14, you borrow $500 from a relative and you agree to pay back the debt at a rate of $15 per month. Okay, so they tell us the two groups, months and amount of money owed. So not how much you've paid back, how much you owed. So how much did we owe to begin with? Well, we borrowed $500 first off. So at 0, that would be $500, right? And then every month we're paying how much? $15 per month. That's the relationship. That's the growth. That tells us where to go. So we have to subtract $15 each month. Now, we could think about this two ways. Okay, the amount of money owed would be $500, and so we could subtract $15. If we just said, the amount of money we're in debt, we could start maybe with negative $500 and then add $15. So there's kind of two approaches, but I think because it wants the amount of money owed, we should actually be subtracting. So 500 minus 15 would be what? 485. Then 470 minus 15, 455, 440, 425, 410, 395, 780. I think I did my math right, did it in my head. So hopefully I didn't make any mistakes. Yeah, I think that was pretty good. So there we go. Then you could say, what kind of model? Could we choose a different model? Yeah, you betcha we could. Okay, we could say, well, we started at 500 and we subtracted 15 a bunch of times, and we could make an equation to try to figure that out. And that could be our model. So then you just plug in 8 and you could figure it out that way. Alright, so 15 and 16, you earn $10 per week. So kind of a simple one to start, but where did we start with? You started with no money earned, 0 weeks. Every week, what are you doing? Adding 10. So you just follow that pattern. 16, you are saving for a bike and can save $10 per week. You have 25 already saved. So I think you guys should be good enough. They've already told you the two groups. Find that pattern, 10 per week. Where did you start? 25. Finish that table. Okay. Just remember, if you wanna start at 0, because before this is already you've started to save $10. Okay. Now, hopefully you have been trying these problems first. Always a reminder. I should have said that at the beginning. Try these first, then watch this to get help. Okay. Now, graph the equations by creating a table and using slope-intercept form. So we've got two ways of dealing with this. Let's do slope-intercept form first. Y equals mx plus b. Okay. So our slope would be -5, but we got to make it a fraction, so -5 over 1. Meaning we go down 5 to the right 1. Or up and to the left. Exact opposite. Our b is our y-intercept, so -4 is our y-intercept. So we start at -4, and we'd go down 5, 1, 2, 3, 4, 5, to the right 1. Or backwards, up 1, 2, 3, 4, 5, to the left 1. 1, 2, 3, 4, 5, to the left 1. Sometimes going back can be helpful. Okay, so there's our graph. Alright, so now if we made a table of it, remember with the table we've got our two variables x and y. We pick some numbers, so like -2, -1, 0, 1, 2, 3, 4. Okay, then we plug some in. So we start with -2 minus 4. That frame we made would help you guys a lot out on these problems. -5 times -2 is +10. Minus 4 gives us 6. So y equals 6. Then we do it for -1. Y equals -5 times -1 minus 4. -5 times -1 is +5 minus 4 is 1. So we get 1. then at 0, y equals negative 5 times 0 minus 4. Negative 5 times 0 is 0 minus 4. Gives us negative 4 now. Remember what we said in that frame. Once we've got three numbers, we should be able to figure out our pattern, right? So on this left side, we added 1. Okay, we have to have a pattern on the x column. Now here we're what? Subtracting 5 each time as we go down. 6 minus 5 is 1. 1 minus 5 is negative 4. Negative 4 minus 5 is negative 9. Minus 5, negative 14. Negative 19. Negative 24, and so on. Now, similarities. So what are some things that you're seeing that's the same here? Well, we had a point right here, right? That point is negative 2, 6. Do we see that? We see right there. We had this point, negative 1, 1. We had that point right there as well. Okay, our y-intercept, 0, 4. We see the y-intercept right here, don't we? Okay, we see that negative 4 number right there. Okay, also look at this growth, negative 5 over positive 1, negative 5, positive 1. Okay, that's slope. So hopefully those are a bunch of similarities that you can see between those. Okay, because they are connected. Alright, last one. So let's start with the table this time. So let's just go like some of you may do. You go like 0, 1, 2, 3, 4, 5, 6. So y equals negative 1/4 times 0 plus 1. Plug in the 0 for x. Negative 1/4 times 0 is 0. Plus 1 is 1. So y equals 1. Okay. Then 1, 1. Y equals, or 1. Negative 1/4 times 1 plus 1. Negative 1/4 times 1 is negative 1/4. Negative 1/4 plus 1. Well, we can change that 1 to a fraction, right? 4 over 4 is still 1. Same denominators. Negative 4 plus 4 is negative, not negative, 3 over 4, which is 0.75. You guys would like the 0.75 better. 2. Y equals negative 1/4 times 2 plus 1. Well, make it a fraction. Negative 1 times 2, negative 2. 4 times 1 is 4. Negative 1/2 is really, negative 2/4 is really 1/2 plus 1. Well, negative 1/2 plus 1 is like 2 over 2. Negative 1 plus 2 is 1 over 2. So y equals 1/2, 4.5. Okay. If we did it for 3, okay, but we should be able to get our pattern. So here we're adding 1. Here we are 1 to 0.75 to 0.5, so we're what? Subtracting 0.25, or in other words, subtracting 1/4. So that should be what? 0.25. This one should be 0, negative 0.25, negative 0.5. And we could check that number 4. And when I say pick smart numbers, this would have been a good number to count by 4s. Because what happens if I take a fraction and its denominator is 4 and I times it by 4, those cancel out. Negative 1 plus 1 gives us 0, so we get y equals 0. Okay, so we could plot it. 0, 1. Isn't that our y-intercept of 1? Yes, it is. Okay, and I'm almost out of time here. 1.75 would be tough, so 4, 0. 4, 0, that's our x-intercept. Okay, that's enough to draw our graph. But if we did our slope, negative 1 over 4, down 1 to the right 4, down 1 to the right 4, same slope. Okay, so differences. Okay, look for some differences here. Yeah, see if there's any differences that you can come up with between this table and this graph and this equation. And there we go. Hopefully you guys are ready for more discussion about this stuff.